When dealing with grounding appliances such as water heaters, there are specific requirements outlined in the National Electrical Code, specifically the 2017 edition in this case. These requirements differ based on whether the water heater is gas-fired or electric. Let's examine the grounding requirements for gas-fired water heaters. The grounding conductor for a gas-fired water heater must be directly attached to the main distribution panel in the building. Additionally, the grounding conductor must be sized in accordance with NEC section 250.66, using the main service feeders to the service panel for sizing purposes. Now let's switch gears and discuss the grounding requirements for electric water heaters. Grounding conductors for subpanels do not need to be directly connected to the main panel. The grounding conductor for the subpanel must be sized in accordance with NEC section 250.122, using the rating of the overcurrent device protecting the feeder that supplies the subpanel. For example, if the subpanel is protected by a 100 amp breaker, a number 4 grounding conductor would be required. Now we discuss the bonding requirements for both types of water heaters. No additional bonding is required to the main panel for a gas-fired water heater. The subpanel is already bonded to the main panel through its grounding conductor for an electric water heater fed from a subpanel, therefore, no additional bonding is required. The reasoning behind these requirements lies in the fundamental purpose of grounding electrical systems, which is to provide a low impedance path for fault currents to safely return to the source. For gas-fired appliances, the grounding path must be directly connected to the main panel to ensure that any fault currents can be cleared quickly and safely. In the case of electric water heaters fed from a subpanel, the grounding path is established through the subpanel's grounding conductor, which is bonded back to the main panel. Therefore, direct bonding to the main panel is not necessary. It is essential to follow these guidelines to ensure safety and compliance with the National Electrical Code. When dealing with electrical systems, safety should always be the priority. Ensure that you are familiar with local codes and regulations, and when in doubt, consult with a qualified electrician. Understanding these requirements helps to protect both people and property from potential electrical hazards. These regulations help to minimize the risk of electrical shock and fire by creating a safer environment. Remember to always prioritize safety and follow the National Electrical Code guidelines when working with electrical systems. The NEC provides a comprehensive set of rules and regulations designed to ensure the safe installation and operation of electrical systems. Compliance with these requirements is crucial for preventing electrical hazards and ensuring the safety of people and property. When installing or maintaining electrical systems, always refer to the latest edition of the NEC and consult with qualified professionals when necessary. The information provided here is for general guidance only and should not be considered a substitute for professional advice. The National Electrical Code is a complex and ever-evolving document, and it is essential to stay up to date with the latest changes and revisions. By understanding the grounding requirements for gas-fired and electric water heaters, you can help ensure the safe and reliable operation of these appliances. Always follow best practices and prioritize safety when working with electricity. Remember to disconnect power before working on any electrical equipment and to follow all applicable safety precautions. Grounding electrical systems correctly is essential for protecting against electrical shock and fire hazards. The NEC provides detailed guidelines for grounding electrical systems, and it is important to follow these guidelines carefully. Always use the correct size and type of grounding conductors and ensure that all connections are secure and properly made. By following these best practices, you can help ensure the safety of yourself and others. Electrical safety is everyone's responsibility. Stay informed, stay safe, and always follow the National Electrical Code. Keep in mind that local codes and regulations may vary, so it is important to check with your local authorities to ensure compliance with all applicable requirements. Working with electricity can be dangerous, so it is important to take all necessary precautions to protect yourself from harm. Always wear appropriate personal protective equipment such as safety glasses and gloves, and never work on electrical equipment while standing in water or on a wet surface. By following these safety guidelines, you can help minimize the risk of electrical shock and other electrical hazards. Remember that electricity is a powerful force, and it should always be treated with respect. Stay informed, stay safe, and always follow the National Electrical Code. Before commencing electrical work, it is imperative to conduct a thorough risk assessment to identify potential hazards and implement appropriate control measures. This assessment should take into account factors such as the voltage level, the type of equipment being worked on, and the environmental conditions. Additionally, it is crucial to ensure that all workers are properly trained and qualified to perform the tasks assigned to them. Regular safety meetings should be held to discuss potential hazards and to reinforce safe work practices. By taking these steps, you can help create a safer work environment and reduce the risk of electrical accidents. Always prioritize safety when working with electricity. It's also important to emphasize the role of regular inspections and maintenance in ensuring the continued safety of electrical systems. Over time, electrical components can deteriorate due to factors such as corrosion, vibration, and temperature changes. Regular inspections can help identify potential problems before they lead to equipment failure or electrical hazards. Maintenance activities such as tightening connections, replacing worn components, and cleaning equipment can help prolong the life of electrical systems and ensure their safe and reliable operation. A well-maintained electrical system is a safer electrical system. Remember that safety is not just a one-time event but an ongoing process. By continuously monitoring and improving safety practices, you can help create a culture of safety in the workplace and prevent electrical accidents from occurring. Always prioritize safety and encourage others to do the same. The National Electrical Code is a valuable resource for electrical safety information, but it is not a substitute for professional training and experience. If you are not a qualified electrician, you should not attempt to perform electrical work yourself. Instead, you should hire a qualified professional to perform the work for you. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also help you ensure that your electrical system complies with all applicable codes and regulations. Investing in professional electrical services is an investment in safety. Finally, it is important to remember that electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By being aware of the hazards of electricity and following safe work practices, you can help protect yourself and others from harm. Encourage your family, friends, and co-workers to learn about electrical safety and to follow safe practices. Together, we can create a safer world for everyone. Always prioritize safety and remember that electricity is a powerful force that should be treated with respect. Always consult the latest edition of the NEC for the most up-to-date information and requirements. Local amendments may also apply, so be sure to check with your local authorities. Consider the specific installation environment and any unique challenges it may present. Factors such as ambient temperature, humidity, and corrosive atmospheres can affect the performance and longevity of electrical equipment. Take these factors into account when selecting equipment and designing electrical systems. Proper documentation is essential for maintaining a safe and reliable electrical system. Keep accurate records of all electrical work performed, including drawings, specifications, and test results. This documentation can be invaluable for troubleshooting problems and for planning future upgrades or modifications. Investing in quality electrical equipment is a worthwhile investment. While it may be tempting to save money by purchasing cheaper equipment, it is important to remember that quality equipment is more likely to be reliable and to last longer. Quality equipment is also more likely to meet safety standards and to protect against electrical hazards. Pay attention to the details. Small details such as proper wire sizing, secure connections, and correct labeling can make a big difference in the safety and reliability of an electrical system. Take the time to do things right and don't cut corners. Educate yourself and others. The more you know about electricity and electrical safety, the better equipped you will be to prevent accidents. Attend training courses, read industry publications, and participate in safety meetings. Share your knowledge with others and encourage them to learn about electrical safety. Stay informed about changes to the National Electrical Code and other relevant standards. The electrical industry is constantly evolving, and it is important to stay up to date on the latest developments. Attend industry conferences, read technical articles, and subscribe to industry newsletters. Seek guidance from experienced professionals. If you are unsure about any aspect of electrical work, don't hesitate to seek guidance from experienced professionals. A qualified electrician or electrical engineer can provide valuable insights and help you avoid costly mistakes. Learn to recognize potential electrical hazards. Develop the ability to identify potential electrical hazards such as frayed wires, loose connections, and overloaded circuits. When you see a potential hazard, take steps to correct it immediately. Practice safe work habits at all times. Make safety a habit and always follow safe work practices even when you are in a hurry. By practicing safe work habits consistently, you can reduce the risk of electrical accidents. Be aware of the limitations of your knowledge and skills. Don't attempt to perform electrical work that is beyond your capabilities. If you are not comfortable performing a particular task, seek assistance from a qualified professional. Use the right tools for the job. Using the right tools for the job can make electrical work easier and safer. Invest in quality tools and learn how to use them properly. Inspect your tools regularly to ensure that they are in good working condition. Avoid distractions while working on electrical equipment. Distractions can lead to mistakes, which can have serious consequences. Focus your attention on the task at hand and avoid distractions such as cell phones and conversations. Never work on energized electrical equipment unless it is absolutely necessary. If you must work on energized equipment, take extra precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment such as insulated gloves and sleeves, and use insulated tools. Follow lockout/tagout procedures to de-energize equipment before performing maintenance or repairs. Lockout/tagout procedures are designed to prevent accidental energization of equipment while it is being worked on. Follow these procedures carefully to ensure your safety. Test equipment before and after working on it. Before working on electrical equipment, use a voltmeter or other testing device to verify that it is de-energized. After completing the work, test the equipment again to ensure that it is functioning properly. Report any electrical hazards to your supervisor or safety officer. If you see an electrical hazard, report it immediately to your supervisor or safety officer. Don't wait for someone else to report it. Be proactive in identifying and reporting hazards. Participate in safety training programs. Attend safety training programs to learn about electrical hazards and safe work practices. Take the time to learn and apply what you learn. Promote a culture of safety in the workplace. Encourage your coworkers to follow safe work practices and to report any electrical hazards that they see. Work together to create a safe and healthy work environment. Remember that electrical safety is everyone's responsibility. By working together, we can prevent electrical accidents and protect ourselves and others from harm. The purpose of equipment grounding is to provide a low impedance path for fault current to return to the source, thereby causing the overcurrent device to operate and energize the circuit. This helps to protect against electrical shock and fire hazards. The grounding electrode conductor connects the equipment grounding system to the grounding electrode. The grounding electrode is typically a ground rod, a metal water pipe, or a concrete encased electrode. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The equipment grounding conductor provides a path for fault current to flow back to the source in the event of a ground fault. The size of the equipment grounding conductor is determined by the size of the overcurrent device protecting the circuit. Bonding is the process of connecting together all metal parts of an electrical system to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same potential, which reduces the risk of electrical shock. Surge protection devices protect electrical equipment from voltage surges caused by lightning strikes or other events. Surge protection devices should be installed at the service entrance and at other strategic locations throughout the electrical system. Ground fault circuit interrupters protect people from electrical shock by detecting ground faults and interrupting the circuit. Ground fault circuit interrupters should be installed in bathrooms, kitchens, and other areas where there is a risk of water contact. Arc fault circuit interrupters protect against fires caused by arc faults. Arc faults are caused by damaged or deteriorated wiring. Arc fault circuit interrupters should be installed in bedrooms and other areas where people sleep. Regular inspections and testing of electrical systems are essential for ensuring their continued safety and reliability. Inspections should be performed by qualified electricians and should include a visual inspection of all electrical components, as well as testing of grounding systems, bonding connections, and surge protection devices. When working with electricity, always follow the principles of hazard control. Hazard control involves identifying and eliminating or controlling hazards in the workplace. The hierarchy of hazard control is elimination, substitution, engineering controls, administrative controls, and personal protective equipment. Elimination involves removing the hazard from the workplace. Substitution involves replacing the hazard with a less hazardous alternative. Engineering controls involve designing the workplace to eliminate or reduce the hazard. Administrative controls involve implementing policies and procedures to reduce the hazard. Personal protective equipment involves providing workers with equipment to protect them from the hazard. Never assume that electrical equipment is energized. Always test equipment before working on it to verify that it is energized. Use a voltmeter or other testing device to verify that there is no voltage present. If you are not qualified to perform electrical work, hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also help you ensure that your electrical system complies with all applicable codes and regulations. Remember that electrical safety is everyone's responsibility. By working together, we can prevent electrical accidents and protect ourselves and others from harm. Always prioritize safety when working with electricity. It is important to regularly check that any generator you use has been correctly grounded. Firstly, that any temporary wiring is installed correctly, protected, and is also correctly sized for the load. Secondly, and equally, that the location of the generator is in a well-ventilated space to allow for complete exhaust of fumes to the outside. Thirdly, ensure that all leads and connections are in good order and free from any damage, and also that the RCD protection is correctly installed and functioning. And it's equally as important to note that gasoline fumes are heavier than air and any enclosed area needs to be thoroughly vented.